Alright, so we're finally at the end of what's been a pretty amazing journey. Along the way we set up our master control and our hips control. We also set up our stretchy spine with the ability to lock the spine in terms of stretchiness. We also gave fine-tune controls so that we could come in and work with changing the curvature of our spine, along with the twist that runs up the spine. If we were to take our shoulder controls and rotate our shoulder controls in Y, we generate a twist along the spine. Talking of shoulder controls, we created both an attached control that will follow along with the hips and a detached control. If we grab our hips now, we're currently blended over to the attached control, and we can come in and grab our shoulder controls and blend over to the detached control, which you'll see will not follow along with the hips. We have the ability to match one to the other or vice versa. So currently we have our detached there, our attach is back there. If I say match attach to detach, we can then have those exist in the exact same space. Or if I was to grab the attach control now, and let's say we move him and reorient him slightly, we could then say match detach to attach, and now our detach control exists in the exact same space. So let me zero those out for a second. Fantastic, and grab our hips and also zero our hips out. Now we applied that concept of attached and detached controls to our head controls and our eye controls as well. So our head controls have an attached version and a detached version, the attached version following along with the shoulders, the detached version not. And our eye controls have an attached version which will follow along with our head, and a detached version that will not. All with the matched attached to detach and vice versa buttons with those scripts to match between them, along with blending functionality. Now we also set up a belly control which can enable us to drive the belly area of our goblin geometry. If we turn on the goblin geometry, if we were to capture that area of geometry with that bone that we set up, we'd have the ability to drive that area. And we also came in and set up the ability to simulate a jiggle on that control, so that any animation, once we have that on the control, if we simulate it, we get some overshoot, we get some oscillations, and we get more of a jiggle feel to that bone rather than a stiff animated just by our animator control for that bone. Now for those of you who joined us in Character Rigging 1, we also looked at getting the rig that we built in Character Rigging 1, both of the arm rigs and the leg rigs attached in to this system as well. And from there we wrapped everything up as an asset, giving the animator easy access to a variety of controls, ensuring that all of the parameters were organized, as well as our viewport display organized in terms of what we can see, and also in terms of a control level of detail there as well. Now off camera, I actually went ahead and hooked up our skeleton geometry. If I hide out our bones and turn on our skeleton geometry, I hooked up our skeleton geometry to the rig. Now this is designed to work without any stretchiness on our rig, so I'm going to turn off overall stretchiness, locking stretchiness on our rig. And all I really did for the most part was go through and parent in the skeleton geometry to our bones by creating nulls that came off the bones and then fetching those nulls with fetch objects over with our geometry and using those as parents of our geometry. There are a few areas that didn't work like that. I'll discuss those in a second. We can jump down inside the asset and take a look at how I got all of that hooked up. So let's just quickly take a look at our skeleton now in motion with the rig, because it really does show some of the very nice flexibility and movement that we can get with this rig. So I could grab our hips and move our hips, causing our legs to move. I can rotate our hips, again causing the legs to move. We can jump in and we can create some nice curvature with the spine. Now you'll notice the spine, if I pull it to extremes, was actually just hooked up in groups, but in actual fact, for subtle spine motions, this works great. Anything that's not too extreme works very nicely with that system. Jump down here to the legs. The legs were the most interesting area for me to set up, because the knee doesn't work quite as a simple parenting. Again, I'll discuss this in a second. And our toes don't work just as a simple parenting setup either. Again, I'll discuss that in a minute. But we can see our knee there does indeed roll up over with the upper and lower bone. If I was to move our foot out the way, we can continue moving our knee and see that that does work nicely. We have control to roll our foot and rotate our foot. And then we can come in and say, hey, let's rotate our toes up based on the toes, and you can see the toes not working just as a parenting. They actually do try and keep the tips of the toes on the floor if possible. We also have the ability to roll up onto the tips of the toes there. Now let's just give some bend to the knee again, and now we can work with that twist, and we can see the twist working to rotate the knee, or the leg rather, at the hip, and also pivoting at the bottom where it attaches to the foot. So there's the leg moving and working. Let's take a look now at our head and our neck in play there. The head following along with that head control, and the neck following along to go up into the head. We have our shoulders. The shoulders were a nice, interesting area to set up because we have both the clavicle bone, but we also have the shoulder blade. The shoulder blade is a really nice, interesting area to get working. Again, I'll discuss that in a second, but we can see we can indeed shrug our shoulders with the clavicle and the shoulder blade going along. And if we were to move that back and forwards, we can see that indeed the clavicle and the shoulder blade do indeed follow along and rotate, hinging perfectly. We've got our arm bones. Let's just demonstrate the arm bones quickly in FK so we can see we have our arm bones there, the ability to rotate those. We also have the ability to come in with our wrist and apply that nice roll that's going to affect our femur and, or rather our ulnar and our radius. The femur is the upper leg bones. Don't quite know why that jumped into my head. But we have the ulnar and the radius, and this is again another area that was a little bit more interesting because we have 2 bones for the ulnar and radius in terms of 2 bones for the ulnar and 2 bones for the radius down inside our asset that we can actually choose to parent to. So deciding which ones to parent to was an interesting decision, but we can see there our bones roll up or cross over, and you can see the bone rolling down at the elbow end there, working fantastically. I also got our hand set up so we can rotate our palm, or we can come in, and I'm going to drop our control level of detail down to 2, grab that control, and we can rotate our fingers there very nicely. Let's boost that back up to 4, and we can come in and rotate our thumb as well. Fantastic. So that's a look at all of the bones, how they're working with the rig. Let's jump up, bring up our network editor, and jump down inside our network and take a look at how some of this was actually facilitated. So I'm going to allow editing of contents, and you can see that for things like the head where the bone follows along perfectly with our geometry, or rather the geometry just needs to follow along perfectly with the bone, I simply wired a null off of the head bone, and then that null sits and is just acting as a point of reference. Then down inside the geometry I fetch that null, so let's see that now. We can jump over into, and rather than the goblin I do want the skeleton. Inside that head subnet we can see we're fetching the head. If I bring up the parameters, there we go, we can see that we are indeed grabbing that 2 head, making sure we use the parent transform of the fetched object. Now I believe that I just put a P in there, so let's go ahead and undo that. Fantastic. So let's discuss, because for the most part everything was just simple parenting, but let's go ahead and discuss some of the areas that weren't just simple parenting. So let's take a look at our arms first, and then we can talk about the legs second, because these were the areas that weren't necessarily simple parenting, or if they were parenting, we had some decisions that we needed to make. So I'm going to jump and take a look at our arm, and we can see with our arm we actually had, if I was to bring up the parameters for our goblin asset and turn off skeleton for a second, bring up our bones, we set up back in character rigging 1, 2 bones for our ulnar and 2 bones for our radius, such that we have 1 bone that doesn't roll when we roll our arm and 1 bone that does. So if we were to roll our wrist, you can see these end bones are rolling, but the top bones, the bones that attach to the elbow, don't roll. This provides a nice set of bones that we could indeed capture our goblin geometry to, but it also provided an interesting choice when dealing with our skeleton. So if we bring up our skeleton, you can see that the radius bone here indeed does need to roll when we roll our wrist. If we roll our wrist, you can see that that bone is designed in order to roll about this point. But if you take a look at the ulnar, you can see that that's more of a typical hinge joint. This doesn't roll when we roll our wrist. It only rotates around when our elbow bends. So to hook this up, I attached the radius bone and parented it into that lower part of the radius that does roll when we roll our wrist, and the ulnar bone I actually attached into the upper part of the ulnar setup where that doesn't roll when we roll our wrist. Moving along from there, the other area of interest with the arm was indeed these shoulder blades. So let's take a look at our scapula. For the scapula, I had a knoll that was parented to our clavicle bone, so that it does indeed move with our clavicle bone, our clavicle geometry bone being parented directly to the clavicle bone. But instead of just having that, that would cause the position to work, but you'd find the orientation of the shoulder blade not working correctly. We need the shoulder blade to still attach to our shoulder down here. So what I did, we have that shoulder position that we were already using from our arm rig. I made sure that our two scapular points and aims at that position, so that when our scapular bone, or rather when our clavicle bone rotates and moves that position, and then our arm of course is going to move along with that based on our rig, we can then come in and make sure that the shoulder blade attaches to both the clavicle bone and also to our upper arm. So I had a null in there that was aiming down at the upper arm, making sure indeed that all functioned correctly. So the rest of the body really worked, or at least the torso and the head worked as simple parenting. The other areas of interest are the knee, so our upper leg, and also the toes. So let's hunt down our leg rigs. So instead of simply setting our two upper leg to be our upper leg bone, instead of just having our upper leg bone, you'll notice if I bring up the parameters, we have a look at, and that's because the upper leg doesn't pivot on the pivot point for our bone. The pivot point for our bone, which is the pivot point for the lower leg, isn't the pivot point for the upper leg. If we take a look at this in motion, so I go and grab our control object. Let's just give Houdini a second to think about this. And there we go. We can grab the foot control, and you can see as the leg is lifted, and ignore the fact that obviously our foot is in an anatomically impossible position right now, we're just focusing on the knee. You can see that the pivot point isn't in the center point really for our upper leg. The pivot point starts out down here towards the back, and that's going to actually slide as it rolls, but we can work with this, and the way that I set that up was to create a knoll that was parented in to our lower leg that was offset from our lower leg slightly in the local Y space. That means as our lower leg rotates up, that pivot point is moving slightly. I then had that knoll that was for our upper leg going to our upper leg, aiming at this slightly offset knoll. That means as the lower leg rotates, it's going to cause this knoll to offset. It's going to cause slightly different rotations on our upper leg. That actually means it rotates slightly further upwards when our lower leg rotates backwards to accommodate that offset in pivot. So now instead of the geometry intersecting, you can see that the geometry indeed rolls over one another. So that was how I achieved our knee. And then finally we discussed that the feet don't work quite the same as a simple parenting. Simple parenting would of course break all our feet apart because the pivot points are in different locations to just our bone. So the foot as a whole is parented into the foot bone, but then from there I created a number of knolls that act as aimers, you can see, in the pivot points for each of the toes. So these were going to become the parents of our toes. And then I created a number of other knolls that are parented underneath the toes bone that are the target location for each of the individual toes. So we had knolls for each of the toes parented under the foot bone, knolls under each of the toes parented under the toes bone, and then we made the knolls that were parented under the foot bone aim at the ones under the toes bone, and that means as the foot bone is rotated up, these knolls are obviously going to move based on the fact that they need to pivot off the end of each of the metatarpal bones. And then we have the fact that we can then aim at the desired foot location, aim at the desired toe location, and that gives us that nice toe motion where the toes feel like they're rolling, feel like they're trying to keep the foot on the floor. So they were the interesting areas in terms of our rig. So let's jump back up a level. Just give Houdini a second to think. Fantastic. and then go ahead, bring up our parameters. So bring up our parameters, and I'm going to turn off the visibility of our skeleton, turn back on the visibility of our bones, and let's zero out those leg values. Fantastic. And so with that, that is going to conclude this project. Now, I do want to talk a little bit briefly about how you could go about capturing the goblin geometry to our bones. All of the bones that are visible in the viewport now, currently, are the bones that you'd want to use to capture the goblin geometry. Now, you may want to go ahead and create a deform rig, if you will, that basically has each of these bones again, but separated from all of the rest of the rig. So out to the side, you'd have a clean rig with just the bones. You'd then drive the orientations and positions of those bones based on the master rig, but you'd have a clean rig to work with. Now, there is a consideration that needs to be made when dealing with the fact that these bones stretch and the fact that we want to capture geometry. If we were to capturing just two bones, we need to take into account the fact the bones are stretching. Because when a bone stretches, let's just hunt down any bone. The left upper leg will work fantastically. We know from when we looked at capturing, we indeed have the deform region as well as a capture region. When the bone changes in length, the deform region doesn't scale effectively. It doesn't change perfectly. And what actually happens is, although the bone changes in length, you're going to find the two end caps of our deform region don't actually change their length, just the middle section changes length. So what you need to do, you need to make sure that the deform top cap and the deform bottom cap in Z, they need to also scale based on the changes in our bone length. So as our bone length scales up, these values need to scale up in proportion to that. As our bone length scales down, these values need to scale down. So for any bone that is indeed stretching, you will need to go through and set up a system where the deformed top cap and bottom cap in Z scale accordingly to the bone length. That will result then in being able to capture your geometry to this bone without getting some really interesting artifacts. But with that, that is going to conclude this project. I'd like to thank all of the staff over at 3D Buzz for all of their support in producing this training product, and especially Jason Busby, who acted as my animator on this project. He threw out feature requests, he kept me on my toes, if you will, as I was developing this rig, making sure that this rig was production ready and ready for an animator to jump in and use. So he was definitely testing out this rig extensively and making sure that this rig was everything that he as an animator needed it to be. So once again, I am Steve Twist, the Director of Houdini Education over at 3dbuzz.com. I hope everyone enjoyed this training product. I hope you benefited greatly from this training product, and do be sure to head over to 3dbuzz.com to check out our other range of training products that we have available. So with that, for the last time on this DVD, that will conclude this video. Thanks a lot, everyone.